All right, so today we're going to continue on with solving equations, and we're going to specifically work on solving equations with variables on both sides. So just to start out, we're going to do some equations where you have a variable on both sides, but the constant is only on one side. So in this type of situation, since we have an x on both sides, but a constant only on one side, you would want to move the variables to the opposite side from the constant. So in this particular situation, if I have an 80 minus 9x on my left, but I only have an x term on my right, I would want to move the x term to the side where there's only an x term. That just makes it a little bit more efficient with solving. So this would be 80 equals 15x. And then, of course, we would just divide to get the x by itself. Now, in this particular problem, 80 over 15 does not divide evenly. So you end up simplifying that to a fraction answer of 16 over 3. Or you could have 5 1/3. So taking a look at the next example, same idea, except this time we are going to add the 12x over to the other side. This way we only have constants on the left and our x terms combine on the right side. And then we would divide to get the x completely alone. And again, this one does end up as a fraction. It only reduces to 32 over 9. Okay. So I'm just going to go down, skip a few till we do a couple more practice down here towards the bottom. Okay, so for number 6, I have x's on both sides, but this time I'm going to move my 16x over to the left since the left side only has a constant. A variable term, sorry. So -2 and -16 would be -18x. And then we would divide both sides by that -18. Giving us x equals positive 1/2 once we simplify. Over here, we have the x term isolated on the left and an x term with a constant on the right. So in this situation, we would want to move our x's to the left. So we're going to add that 28x, giving us 32x on the left and a -3 on the right. Dividing to get the x alone. And again, we have a fractional answer here of -3 over 32. Now, doing the next two problems here, you'll notice that I have a 12x on both sides. So when I go to subtract the 12x to get my constant alone, it just so happens that all of the x's cancel. So my -4 is all by itself on the left side, and 12x minus 12x just leaves you with a 0. Whenever all of your variables cancel, whatever you're left with is going to tell you what kind of solution you have. Is it no solution or is it infinitely many? In this case, it's going to be no solution because -4 does not equal 0. It's a false statement. If you ended up with -4 equaled -4 or 0 equals 0 or something that's true, then it would be infinitely many solutions. So let's try this for letter J. So again, I have an x term on both sides of the equation, but the left side is where my constant is, so I'm going to move my x term to the right. So now I have just the 12 on the left, and then I have 48x on the right, dividing by my 48, and that simplifies to a fractional answer of 1/4. Okay, so moving on, we're going to continue working with this, but this time you'll notice the problems have both an x term and a constant on both sides. So you can move your x's to the right or the left this time, whereas in the last page, there was definitely an advantage to moving it one way or the other, depending on what was alone. So what I typically do, now you could move your constants first, but I think it's a really good habit to get into moving your x's first. For some reason, I have some students that always insist on moving the constants first, and you can still solve it that way, so it's not that big of a deal. But I just feel like it stays a little bit more organized. You have a little more control of how it's going to work out when you move your x's first. And what I mean by that is In this situation, I have an x on both the left and the right. I have a constant on both the left and the right. Well, if I move my x's to the left by adding 2x, I will get a positive 9. But if I move my x's to the right by subtracting 7x, I will get a negative 9. And ideally, the problem will be a little bit easier if I have a positive x, because then I'll be dividing by a positive when I get to that point. And so it may be one less step of work, or it may just help you not have to worry about canceling out negatives or things like that. So in that situation, I always like to move the smaller x value and then go from there. So this gives me 9x. Now, because I moved my x term to the left, I have no choice but to move my constant term to the right. So 55 minus 19 then gives me 36. And then now I'm just dividing by a nice positive 9. I don't have to worry about a negative. And I get 4. Now, had you done it the other way, you would have ended up with a negative 9 and a negative 36, and you would have had to divide a negative by a negative. You still would have gotten a positive 4. Okay, so taking a look at example B then, we have an x on the left and the right. Now, if you look at these two, the negative 3x is smaller, so that's my preferred term to move over to the other side. So since my x is moved to the left, I'm going to move my 22, which is my constant, to the right. Then I finish up by dividing, getting my x alone, and I end up with x equals 1. All right, so I'm going to skip down a couple problems. So I'm going to skip down to G and H here. Okay, so now for example, G looks very similar to the one we just did. So I'm going to move my smaller x term to the opposite side. In this case, that would be adding my 3, which is going to give me a 15x. And then I'm going to move my constant, which is the 7, to the opposite side. So that's going to give me a 15 there. And then dividing, and I get x equals 1. All right, so let's take a look at H. So for this one, my smaller number here is the negative 12. So this time I'm going to add 12x, which is going to move my x value to the right. So now I have 4 equals 20x minus 6, which forces me to move my 6 over to the left. So I have 10 equals 20x, dividing by 20, and I get x equals 1/2. All right. And I'm going to do one more here. So here we have a 4x, a 6x. So of these two, my smaller value is the 4. So I'm going to go ahead and move my 4 over by subtracting it. So now I have negative 7 equals 2x minus 5. Moving my constant now to the left. So I have negative 2 equals 2x. And this time when I divide, I'm going to end up with a negative 1 for my answer. All right, now looking at these bottom two examples, you might notice that there's actually 2 x terms on the left and 1 x term on the right here. So you could say, or you might say, well, since there's more x's on the left, I'm going to move this one to the left, and that's totally fine. But before I move anything, I would want to combine like terms and condense any x's from the same side together. So 1x minus 2x is negative x. And then the rest of it, I'm just recopying. Okay, so now I can go ahead and add that x over. And when I do that, look what happens. They both cancel, and I'm just left with this 3 equals 3. Now, of course, that is a true statement, so that means that there are infinitely many solutions, or as I like to say, IMS is our solution here. All right, and then finally looking at example L is another similar situation where we have 2 x terms on the same side. So I'm going to go ahead and combine those first. All right, and now I'm going to go ahead and move my x's. Now look at again here, I have negative 6x on both sides. You might be like, well, which one's smaller? Which one do I move? Obviously, they're the same, so it doesn't matter, but this is also a clue that when they're the same, you're going to get one of those special solutions. So the x's will all cancel, and you're left with 7 equals negative 3. Now, in this situation, that is a false statement. So that means there is no solution to this problem. Technically, it's no real solution if you remember our discussion on real numbers. But that's all you're going to do for that. All right, so moving on to the next page. Now, not only do we have, now we're going to have not only variables on both sides, but also some distributing that we need to do. So before you move things from one side to the other, you really want to get rid of those parentheses first. It's very similar to the order of operations, otherwise known as PEMDAS. Parentheses is that first step. Same thing when you're solving an equation, just get rid of them first. Now we use the distributive method to get rid of our parentheses. So remember that the number in front of the parentheses as well as the sign that's in front of it are getting distributed together. So in this case, it's a negative 4 that we're distributing. So negative 4 times x is negative 4x, and then a negative 4 times negative 3 would give me that positive 12. And then now we're back to where we were on the last page, trying to get all of our x's on one side. Now notice on the right, I only have an x term. On the left, I have an x and a constant, so it would make sense for me to move my x term to the right since that's the only thing I have on that side. If you did try to move it away, you'd have to put in a 0, and a lot of times people forget to do that, and then they get messed up with their signs. So this will leave me with 12 equals 3x, which I can then divide, and then my answer will be x equals 4. All right, so I'm just going to go down this column here on the left. Okay, so then if I look at example C, okay, this time I'm also distributing a 4, but notice there's also a negative in front of it again, just like in the last problem. Sometimes with the number in front of the negative, people are like, oh, it's a minus sign. Doesn't, no, it's still with that 4. It stays with that 4. So I have an 8x. Negative 4 times negative 5 will give me a positive 20x. And then the negative 4 times the negative 2 will give me a positive 8. Now I'm combining the like terms that are on the same side of my equal sign. And now I'm going to move things to opposite sides. X terms on one side, constants on the other. So I'm going to move my 28x over since this side only has an x term. Makes sense. 8 equals negative, let's see, 16x divided by negative 16. And that simplifies to 1/2. And of course, it's a negative 1/2. Okay, letter E, we're distributing this 3 here. It's a positive 3, so we have positive 3x plus 6. And on the other side, we also happen to have a positive 3x plus 6. Now, before we even do anything, you might notice that this is infinitely many solutions because everything's exactly the same on both sides. So when I go to move my x to the other side, you're going to notice that they're both going to cancel, and then you're left with the same thing on both sides. So this is infinitely many solutions. It's also sometimes known as an identity problem, and that I always think of that as like your identity is like who you are. So if you look in the mirror, right, you see your identity. Same thing here, 3x plus 6, looked on the other side of the equal sign, saw 3x plus 6. Okay, so for example, G, now this time you see the minus sign in front of the parentheses without a number. That means it's really a negative 1 that's going to get distributed here. So we have a 6x minus 3x and then plus 6 because the negative times the negative. Now I'm going to combine my like terms that are on the same side of the equal sign. And now I'm going to bring my x's to one side and my constants to the other. In this situation, I'm going to move my 3x because it's smaller than the 5x, and that will give me a positive. But you could do it the other way if you'd like. So this will force me to move my constants to the left. So I have 10 equals 2x. Now if I divide by 2, I end up with x equals 5. All right, letter I have two things to distribute in this problem. The -2 over here on the left, giving me a -12 and then a positive 20x. And then over here on the right, I have a positive 20x and then a negative or minus 60. So when I go to move my x to the other side, whether you're going left or right, doesn't matter. Both of my x's cancel. I'm left with -12 equals -60. That does not equal each other, so this means there is no real solution. And then finally on this page, last one, we're going to distribute this 5 and this -2. So on the left, I have 5x minus 10. On the right, I have -24 plus 18x plus x. So my like terms over here on the right are going to get combined. And that is going to give me a 19x. And now I'm going to bring all my x's to one side. So since my 5 is smaller, I'm going to move that one. That's going to force me to move my 24 to the opposite side. So that's going to give me 14 equals 14x, which of course, then you divide and you get x equals 1. All right, so let's go into some of these fraction problems. Okay, so yesterday we had talked about solving equations with fractions, and we talked about that we could use the distributive method or the reciprocal method. And for the problems we did yesterday, because there was only one product on each side, there was no addition and subtraction going on. Like here you see this 10 minus 3 times x minus 2. So if you were going to do reciprocal for something like this, not only would you multiply the 4 to the 1/4, but you would have to also do it to the 10 and this here. So it gets a little messy. So the first thing I would do is look to see what you need to distribute, that's a fraction, and see if the two numbers you're going to distribute to are divisible by that denominator. So is 12 divisible by 4? Yes. Is 16 divisible by 4? Yes. If it is, distributing is going to be your best bet. So when you're distributing a fraction, 1/4, remember these are really like over a 1. And when you multiply a fraction to another number, you're multiplying the two numbers on the top and then the two numbers on the bottom. So 1 times 12 is 12, 4 times 1 is 4, and 12 over 4 is just 3. You could also think of that cross canceling there with the 4 and the 12. Now 1/4 of 16 is 16 over 4, which is 4. Over here, I'm going to distribute my -3 to x and -2, making it a -3x plus 6. Now in this problem, my like terms I have are constants. 10 plus 6 is 16. And then on this side, I have 3x plus 4. Okay, now this time I want to bring my 3x to the left, or my -3x, since that's smaller. I'm going to add that. I'm going to add it over here to the left. I get 6x, and that means I have to move my 4 to the opposite side, and that gives me 12. And then I divide, and I get x equals 2. Okay, moving on to the next problem over here on the right, B. Now this time, our fraction that's going to be distributed has a numerator as well. So we have 2/3. Again, if you were to do the reciprocal method here, you would multiply by 3/2 to cancel that fraction, and you'd have to multiply the 6 by 3/2. So that's an option. If you distribute, however, both 6 and 3 are divisible by 3, so distributing works out quite nicely, so I'm just going to stick with that. So remember, these are really over a 1. So 2 times 6 is 12, and 3 times 1 is 3. And of course, that simplifies to 4x. And some of you may be able to do that in your head. What's 2/3 of 6, right? 2/3 of 3 is 2, but if you weren't sure, 2 times 3 is 6. 3 times 1 is 3, and then you would just divide it and simplify it from there. And then on this side, we have 6x minus 18. So now we're just getting all of our variable terms together on the same side. I like to move my smaller of the two x values, which in this case is the 4. That way it ensures I get a positive x value. Then I'm going to move my constant to the opposite side, which gives me a 20. And then, of course, to finish it up, I'm going to divide by 2, and x equals 10. Okay, let's go to example C. Again, 1/5, not a bad option here to just distribute because 10 and 15 are both divisible by 5, so this fraction will actually cancel out when I distribute. So 1/5 of 10 is actually 2, in this case 2x. 1/5 of 15 is 3. And now I'm going to move my variable. Negative 2x is smaller than positive 2x. That's the one I'm choosing to move over. So now I have 4x minus 3 equals 3. I have to move my constant now to the opposite side. So 4x equals 6. And then when I divide, I'm going to end up with a fraction, 6 over 4, which I can simplify or reduce to 3 over 2. All right, so then let's take a look at D. The 1/2, once again, check it. Is 12 divisible by 2? Yes. Is 4 divisible by 2? Yes. So it would make sense for me to just distribute this fraction. Half of 12 is 6, so 6x. Half of 4 is 2. You can see it works out quite nicely as long as those are divisible by that bottom number. Now, negative 10 is smaller than 6, so that's why I want to move my 10, but you definitely could move the 6 over. It'll still work. So now I have 16x. Of course, my 2 has to go to the opposite side, giving me a 16, and then I divide, and I get x equals 1. All right, moving on to example E. Okay, once again, these two numbers in here are both divisible by 4, so I can just distribute my 1/4. 1/4 of 60, or 60 divided by 4, is 15. 1/4 of 16 is 4x. Now notice this time, this is what I was saying to you is an identity, because you see the exact same thing on both sides. So when I go to subtract my x, that's going to cancel, leaving me with 15 equaling 15. So does 15 equal 15? When 15 looks in the mirror, does it see 15? Yes. So that means it's infinitely many solutions. So anytime you have an identity problem like that, it's infinitely many solutions. All right, so now let's look at this next one. This time we're going to multiply by 3/4. We have a numerator other than 1. But again, deciding whether to do this, how to do this or not, if both of these numbers here, 24 and 8, are divisible by this 4, that's really all that matters to decide, yes, distributing is a good option here. So 24 times 3 is quite a large number. I believe it's 72. And then on the bottom, you'd have 4 times 1, which is 4. And you distribute over to this side, you have 3 times 8, which is 24, and then 4 times 1, which is 4, and there's your x. Now, you can do it that way. That's totally fine. I personally, though, I see the 4 and the 24, and I just want to say, okay, 4 goes into 4 ones, 4 goes in here 6 times, and then 3 times 6 I know is 18, and I just go straight there. If not, 72 divided by 4 is 18. Same thing when I distribute the 3/4 to the 8. 4 and 8 can reduce to a 1 and a 2. 3 times 2 is 6. So again, 24 over 4 is 6. So it doesn't matter which way you do it. Now distributing the 2, you get 10x plus 2. And now we're getting all our x's on one side. I'm choosing to move my 6 because the negative 6 was smaller than the 10. So 18 equals 16x plus 2, subtracting the 2. That's going to leave me with 16 equals 16x, which of course, when you divide out, you are left with x equals 1. All right, so after this, we just have some word problems, which I will post on a separate video.